Hi guys, my name is Musa Abdulkarim, popularly known as Wise Mr. Musa, and this week I'm going to be sharing with you what I learned in the past 2 weeks, which is basically smart contract. So in the first week, we talked about blockchain, which is simply a way of storing information in a cryptographically secured way and chronological order. So we talked about Bitcoin being a blockchain and also the Ethereum being a blockchain. So basically in Bitcoin, it's a cryptocurrency which you can use to transact. So the difference between it and the Ethereum is that the Ethereum, in conjunction with having its own cryptocurrency, which is the Ether, it also has what we call the Ethereum virtual machine, and this virtual machine is Turing complete, which means that it can run any computation. So the fact that it can run any computation on it, it gives us the opportunity of writing what we call the smart contract. So we talked about two types of accounts that we basically have under this. We talked about the externally owned account and the contract account. So we said that transaction is what makes an Ethereum machine to tick. So which means that it's transaction that causes a state change. And whenever we have a transaction can has message in the message of the transaction, it can has data or value. Whenever a transaction has data, it is called payload. So and whenever it has value, the value is used for transaction. So any transaction that passes only value is called payment. Any transaction that has only data is called what? Invocation. And any transaction that has both uh, data and value is both payment and what? Invocation. So whenever we make payment, we can make payment to another from an externally owned account. You can make payment to another externally owned account. So when we have invocation is simply you calling another a contract account. So when you call a contract account, then that contract account can be triggered and whatever is written in it is going to be run. So when we have an externally owned account, a transaction is always originated can only be originated from an externally owned account, which is because, and the reason is because any transaction that you are going to be starting, it has to be signed, and it is only externally owned account that has private key, that is you can sign them, but a contract account, it doesn't have private key, which means that it cannot sign any transaction. So when we now talk about these smart contracts, in the previous week, in last 2 weeks, the last video that I made, I talked about what? The Solidity. So basically you use Solidity is one of the languages that is used for writing programming languages on the Ethereum virtual machine. So with this Solidity, we can write whatever type of smart contracts that is basically what? A logic that whenever it is triggered is going to perform whatever function that you've asked it to do. Now, we also talked about the EIPs, which is the Ethereum Improvement Proposals. So in this Ethereum Improvement Proposal, we have different types of what? The EIPs. We have the standard, we have the network, and we have the one that informational. So under the standard, we also have four types. We have the metadata, we have the ERC, and we have the core and the network. So under the ERC, which is Ethereum request for comment, so are that's where some EIPs are explained. So we are going to be looking at, so what we learned in this week are some of the EIPs that we have. So in last week, we started by going through the EIP 20 proposal, which is basically talking about what? Token. Now, what's a token? A token, while we know that the Ethereum itself, it has its own native currency, so which is the Ether. So it is possible for you to create a token, which is like another currency. So when you create this token, you can make it whatever you like, but the standard that you are going to be using in order to create them is explained in the EIT 20. in the EIP 20. So that EIP 20, we now have ERC 20, which looks at the implementation of it. Then we now have different, companies that create a standard that you can make use of in order to make use of this EIP 20 or ERC 20. So one of these companies is actually the Open Zeppelin. So last week, what we did first was, okay, we read the EIP 20 and we wrote a code that implements it. And after we were done with that, like understanding everything that goes on, then we went further to look at the standard of Open Zeppelin, the way it is used. So after that, we were also asked to write. We were given an assignment to create a voting. It's basically a voting contract that uses that EIP 20 to do that. So I'm going to be walking you through my code for all those things that we actually did in the past 2 weeks. But the other EIP that we also looked at is the EIP 721. So the EIP 721 is the one that talks about non-fungible token, right? So, and the non-fungible token basically is the one of NFT. So we used that one also in order for us to create the NFT. We created NFT project. So I'm going to be walking you through my code for both EIP 20, like basically just walking you through the assignments that. So I'm going to be starting with this, which is my voters. So let me. So in my so this is the first as let me say the assignment that we created. So basically what's happening here is that I created a smart contract. So the question asked us that we should create a tokenized voting platform, that is a vote. It's just so my implementation is that we have a factory contract. So basically what a factory contract is a contract that is used to generate other contracts. So here I have two interfaces here. So I have ballot and I have what PVC. So in this place, what I did was that this PVC here is an implementation of the ERC 20 standard. So which means that here you can buy a token. So you need to buy a particular token before you can vote. So this ballot here is my contract that talks about, that implements the voting. So what it basically does is that okay, it has a constructor function, which means that whenever you want to call it, so you are going to require the name of that particular ballot, then the contenders, the period you want it to be, the amount of token that is required for anyone that wants to vote there to have, and the address of that particular token, of the token platform. So in this case now, it requires that you must put at least 3 people there, just 3 people actually for this particular case. And you have the option of when you vote. So before you can vote, it requires that the voting time period hasn't ended, and also you have enough token, to vote. So when you vote, the voting is more of ranking period. You are going to rank those 3 people. The first person that you rank, the first person is going to have 3 points, the second person is going to have 2 points, and the last person is going to have just 1 point. And when you vote, it's going to indicate that you voted. Then it also has another function that you can use to return the winner, and of course you can also get what the voters addresses. So in this factory here is where you can, a particular person can just create a ballot box, and the person is going to put the name, the contenders, the period you want it, and the amount of token that you want to have per vote. And this is the when I deployed it, this was where my PVC token, that's the contract address of my PVC token. So then we also wrote script. We now wrote a script that basically, so I have this script. It deploys it on the mainnet. So this one, it deploys it on Guali. So we wrote all these different scripts in order to interact with it, and we made sure that it was working. So this was one of those things that we did. So then we also actually wrote test. So the eviction test for this court, the first eviction test, we wrote it, and we expect the results to be announced maybe next week. So I'm going to walk you through my implementation of the test question. So in the test, actually, we have 2 questions to answer. And the first one was that we should create an NFT. We should create an NFT and deploy it on the test net, that is the Guali test net. And the NFT, we have to make sure that it shows on the OpenSea. So which means that basically for the first question in the test, the major point is that it has to show on the OpenSea. So for this particular one, what I did was that I made use of the Open Wizard of the Open Zeppelin contract wizard. So I used the ERC 721. I'm going to show you. So this is basically my code. So I used the ERC 721 of the Open Zeppelin implementation of ERC 721. So, and I have a function here which is save mint. So in the question, we are asked to send the NFT should be created to the account of only the owner of that particular of the smart contract, and that was just what I implemented there. And after that, I created a script. So I used this script to deploy it. So in the script, you see that we have the CID. So the way it works is that when I wanted to publish mint a particular picture on the NFT. So I used firebase.com. And to upload my picture. So when I uploaded the picture, then I also uploaded the metadata. So the URL that I got from the picture that I uploaded, so I included it in the metadata.json. So I included it in the metadata.json. So I have the metadata.json. So this the description of the image and the traits of values of that particular image. So when I did that, then I uploaded the metadata also. I uploaded the metadata.json also into my NFT. So, and I got this CID. So in my script here, so in the script that I used for minting the NFT, so I asked it that when I get the CID, so this is the CID that I got, then the URL is going to be the CID with the prefix of IPFX ://. So when I added that, then I now call the function of save mint on the, so which eventually minted. So with that now, I have my I minted my contract. So basically you can see the number of NFT projects that I am able to mint on the open. So I basically minted all of this. So I want you to look at all of them. So while I'm expecting it to load, so I minted all of this on the, so I think my network currently doesn't allow me to do that. So that was the NFT. Then the other question is about interacting with the Uniswap. So in order to do this, so for the Uniswap project, so we actually used the Uniswap. We go through their documentation, their smart contract. So we now wrote out, so the token, some of the token, it uses the ERC20. So which means that all tokens that uses the ERC20, so we can use the interface to interact with them. So that's the reason why we have the ERC20 here, and here we have the Uniswap itself, the interface of the Uniswap itself. So for the second test question, we are asked to call these three functions: add liquidity with Ether. So the first one is you are adding liquidity using two tokens, and the second one is using Ether, and the last one we are removing liquidity. So in order to do this, what we made sure was that, so we actually learned a lot about while doing this. So we learned about how to make use of ADAT to, to create the forking of the mainnet. So we had to fork the Ethereum mainnet, and we looked for the contract address of someone who has enough. So we looked for the contract address of someone who has enough Ether in their account, and also has two tokens that we are going to be interacting with. So then we also used a function that helps us to impersonate a particular address, because if you want to interact as any address, you have to have the account, the private key of that person. So in case you don't have the private key of the person, and for educational purpose, you need to learn how to interact with it. So you can the ADAT, it has a module that basically helps us to do that. So this one, in the ADAT network helpers, we have the impersonate account, which we used, and using this, I'm able to interact with Did in the past 2 weeks. So it's really a very intense week. Like, we did lots of learning, writing scripts, interacting, like forking the main network, impersonating accounts, like doing all of that, creating NFT, creating tokens, and all of those. So those are the things that we learned, and I want to make a special shout out to our tutors. Of course, our instructor for the past 2 weeks has been Miss Ruraola. So she actually did a lot in making sure that all of us were carried along, and I'm going to say that these 2 weeks actually, it wasn't very easy, but she made it to look as though it was just a normal stuff for us. So we really appreciate that, and also the contributions of our past tutors that made us to understand what she was saying very easily. That is Mr. Abims and Mr. Kelvin, and also to the management, to the entire management of the Web3 Bridge, Mr. Mr. Ayo, Mr. Ayodele Aoshika. So I say a very big thank you to all of them. So this is what I have learned in the past 2 weeks, and I hope we meet again next week. Bye.